This is Marcella Cates from MAP. Welcome to the webinar, How to Survive the Structural PA66 Shortage, presented by Polysource, a proud sponsor of MAP. A few housekeeping items before we get started. For the MAP members, we will be recording this webinar today and it will be up on the website tomorrow under the Events Archive tab. Make sure you log in first in order to get to this page. And if you need help finding it or logging in, just contact the office and we'll help you get there. We have a very large group on the line today, so we'll be keeping everyone muted throughout the presentation. But we encourage you to use the question box to ask questions as we go through the presentation, and we will get to them as we go through. We will also have additional time at the end to ask any further questions if you need to. If you have any logistical issues, you can also use the question box or the chat feature, and I will help you troubleshoot. So with that said, I will turn it over to Jeff and Cliff.
Good morning, everybody. This is Cliff Watkins with Polysource. I'm the Director of Applications Development, and I'm one of those quintessential old guys in plastics, as our industry is known to have. I've been around for about 30 years. I spent first half of my career at PPG Industries in the fiberglass business. Then I had a compounding business called TP Composites, and I've been with Polysource now for a little over 3 years. And it's a pleasure to take some of your time this morning and talk about nylon 66 and hopefully help each of you find a way to get through what we are concerned could be a real significant supply situation as the year and next year progresses. So really the point of view that I bring to you today is, in the past, and I think anyone that's been in the industry for a little while will remember, we've had chronic issues with ULTEM over the last 10 years. We had the Evonik plant explosion that led to the nylon 12 global mess. In the last 2 years, we've all been enjoying the mess, or the mother of all messes, with the SABIC SAP conversion. And now, since the second half of last year, we've had a large number of force majeures in the nylon 66 space. What's different about this is that each one of these force majeures has been telegraphing that a problem is coming. And so today, the focus that I bring is, there's a problem that's coming. We want our customers, we want our industry to be aware of what could come. I don't have a crystal ball, and I can't tell you for sure that what concerns us at Polysource will be as bad as I think it might be. But this is one shortage that we actually have the opportunity to be prepared for, to do a better job of communicating to our customers, and to take action in a number of different areas. I love this quote that I think everybody has probably heard in one form or another about, he who forgets history is doomed to repeat it. So why is nylon 66 so tight? Well, nylon is actually a pretty simple polymer to produce. You take HMDA, or hexamethylene diamine, which is a mouthful. You mix it with adipic acid in water, and you essentially boil water, and you get nylon 66, and you get water. The more water you drive out of the reaction, the higher the molecular weight. We're going to talk today one step back in the supply process, and that is the ADN, or adiponitrile. That's what's in worldwide shortage and causing issues for all of the nylon 66 producers. ADN is a precursor to the HMDA. So if you don't have ADN, then you don't have the diamine and you can't make polymer. So there are two routes to ADN, and I won't go into a lot of the detail, but one is based on butadiene, and this is the original DuPont process. And then the other is a route developed by Monsanto back in the mid-50s, which starts with propylene plus ammonia, and through several pretty interesting chemical transformations, you end up with ADN. No matter how you make adiponitrile, you're talking about hazardous chemistry that's highly specialized in big factories that are expensive to build. So as I used to joke with people, you don't just go to Kmart to the ADN aisle and generate another plant. It takes a lot of time, planning, and capital. So over the last 10 or 12 years, there's been some significant changes in the nylon 6/6 supply chain. Today, most of the ADN comes to polymer producers via the merchant market, because most of the ADN is made by people that make it and sell it on purpose, as opposed to years ago when DuPont was in the business. ADN was part of their captive supply operation, and they viewed ADN as a cost center, not as a profit center. And so they built their capacity around end Zytel production that they needed based on their view of applications development. When you move to a merchant point of view, you don't have all of the line of sight to applications that are being developed, because you're selling to somebody who's making polymer, who is in some cases doing development, and sometimes they're just making polymer for the merchant market as well. So at this point, the only captive producer for ADN is Ascend, which some of you know as used to be Solutia, and traces its roots all the way back to Monsanto. So if we take a look at who's making nylon 6/6, well, here in the U.S. you have Ascend, what's now called Dow DuPont, and Invista. The Invista business used to be part of Dow, used to be part of DuPont, but they spun it off, and it's now a completely separate business. There are long-term supply contracts from Invista back to DuPont from the time of the spinoff. And then you have Ascend, which is a fully integrated production complex down in Florida. And as a side note, the Monsanto facility in Florida was actually built and designed by DuPont in the early 50s as part of a means for DuPont to alleviate antitrust concerns. After the plant was built, the Monsanto scientists then came up with their route using propylene to get to the ADN polymer. So their route's a little different than the way DuPont used to make it and the way Invista still makes it now. So as you look through this slide, what jumps out at you by design is that there's three people that make ADN: Ascend, Invista, and Butachimie, which is a joint venture between Solvay and BASF. So you have 100% of the ADN supply being made by 3 suppliers and 4 sites. Everyone else on this list buys ADN from those 3 people. So what you end up with is a highly concentrated commodity with a small number of chemical companies buying a lot of material from a small number of producers. So you can appreciate that in the world of commodities, when you've got big buyers and a small number of producers, it can get at times, if demand is outstripping supply, you're in a situation like you are now. A few years ago, supply was outstripping demand and prices fell. And that put the ADN producers in a tough spot because they couldn't justify adding capacity because the return on investment was there. And remember, these are big, expensive, hazardous plants to build, so you don't make the decision to put on capacity without a lot of forethought and a lot of financial wherewithal to do it. So where a number of different opinions kind of collide and converge is there enough ADN supply? And what nobody really knows are the 2 things. What's going to happen to the global economy, and really what's going to happen to car builds? I'll show you a slide in a moment that as car builds go up and go down will directly affect how much nylon 6/6 is available. And so again, coming back to the premise for the discussion today is you need to be prepared that if all things align in the best possible way, which could also be the worst possible way, there's going to be a very strong shortage, disconnect between demand and supply of resin. And so what our message is today to everybody is be thinking about where you are in the supply chain, what markets you're serving, and are you prepared and is your customer aware of what could happen? And it's all about could, and with your customer and in some cases with our help with Polysource and your other suppliers, laying the groundwork to be prepared if you can't get polymer. So when you take a look at global nylon 6/6 demand, roughly 60% goes into automotive, and it's either directly under the hood or the electrical components. So automotive is a very, very large mega segment for demand for 6/6 polymer. So I call it the Pac-Man effect, and you can see why. You've got power tools, material handling, cable ties, general industrial, just as some catch-all segments to really highlight the fact that automotive will be dictating who gets what polymer. And I say that from the standpoint that Daimler-Benz, General Motors, Ford, FCA, the Japanese transplants, they're going to be the ones that have the big supply contracts and are going to be wielding the leverage to make sure that they are able to get 6/6 polymer to be able to sell their cars. So it's the non-automotive market, as you start to segment down, where I foresee the supply problems coming in. So again, if you're in the automotive market, you might be a molder, you might be a device manufacturer, and I didn't look most recently to see if we have anyone such as a Bosch or an Eaton that would be a tier 1. But at the tier 1 level, a number of folks like Bosch and Eaton have global supply contracts for all of their major resins. They're buying, in some cases, 20 to 30 million pounds of nylon materials. So they're going to have supply contracts. They're going to have pricing, and they're going to be well aware of this situation in terms of the tightness of supply and also what's happening with price. So message number one, if you're in the automotive market, I think you're most likely going to get resin, because I think we all can recognize the reality that the ability to change a material from 6/6 to something else that hasn't already been switched out is unlikely to happen. I mean, that's just the reality. So you're going to get resin, but as you've started to see, you're going to see some pretty dramatic increases in price. My estimate is that pricing is already up at least 80 cents a pound since last October, and that's going to vary a little bit on where you're a small, medium, or large buyer. The lowest price guys are going to see the biggest price increase. So the message, you need to be in touch with your customer, you need to be in touch with your OEM or your tier 1. You want to make sure you're all on the same page on what you're seeing, what they're seeing, and the message here is communicating. So if you're in the automotive business, you're going to get nylon, but you've got what potentially I see as a very significant profit margin problem, because you may get resin, but your price is going to go up. And so if you haven't worked out and communicated with your customer about how to deal with these rapid, little lead time and no negotiating on what's happening with 6/6 pricing, you could find yourself selling parts and losing more money on every part. So you've got to be in touch with your customer. You need to be asking questions to find out if there's price protection from your tier 1. You want to make sure that if there is, that your supplier is keyed into that price protection and that you're getting the proper price for what you're paying. The other thing, and this last one on placing orders, this comes from 30 years of experience. if you don't have actual orders in with your supplier on a regular basis for what you're going to need, you're not going to be visible to them in terms of your requirements. Do not rely on a blanket order. In shortages like this, the only thing that is going to be used to manage supply is actual orders. Blanket orders generally are not, especially in a shortage, people are not going to build to a blanket order. So get your orders in. The other thing is, this year especially, we've seen 3 price increases. And so if you have inventory that you bought in June and then you sell parts in August, you want to make sure that your piece price is based on the price you would pay in August. We call that in the distribution business the replacement cost. Why is that significant? Because you need to keep moving your price up as resin prices go up at the time that they go up, because you'll have a hard time coming back in 2 months or 4 months or 6 months and so, oh gee, I missed 2 price increases and I need to pass through 50 cents in resin prices. I think you're gonna be in a world of hurt. So you've got to keep moving your price up as resin is going up, and the next price increase is August 1st. So, and again, this is a tenet that we follow in the distribution business. You've got to sell on replacement cost, not on what your inventory cost is, because you'll quickly fall behind. So then looking at the other half, the smaller half of the Pac-Man chart. So if you're a non-automotive application, this is where I'm most concerned for our customers and for our industry, because you're the folks that when things get tight are not going to get material. And it won't even be a matter of, well, gee, I'm willing to pay a higher price. It just simply won't be available. So not only aren't you going to get it, and what you're going to get is going to be at an incredible price. And again, I'm being a little bit overly dramatic to make the point that this is the time to be prepared, to be communicating with your customer and be planning for the alternatives. So if you're not automotive, turning it around the other way and looking at it as the glass is half full, because of the way nylon 6/6 prices have gone up, you actually have a profit opportunity, because you can take potentially new materials for consideration to your customer at comparable prices to nylon, but where the cost is lower than nylon, and obviously price minus cost is margin. So if you're buying materials at a lower price and selling them at the same price, you've got an opportunity to put some money in your pocket. And again, this is where the savvy user and savvy customer need to get together and figure out where there are opportunities. And in many cases, especially in non-automotive, as I'll show you in a minute, there are still 6/6 applications that could easily be changed to other polymers. And of course, I always use easily with the air quotes. Nothing is easy, but this is the kind of environment where people are going to be hyper motivated to really take a look at options when the first message you deliver to them is, I can't supply you parts because I don't have plastic. There's no greater motivator for someone when they're faced with such a dire situation. Be proactive is really the message here. Because again, coming back to it, this is an opportunity that we didn't have before. We know things are going to get worse. I can't tell you how worse they're going to get. I have a feeling they're going to be significantly worse, just from what I'm seeing in terms of automotive demand. But the time is now to lay the groundwork with your customer about what options might be out there, and to get them thinking about, what are we going to do? And so that leads us to, well, what do we do? What does Polysource do? Well, the first thing we're going to do is we're going to take your current material and we're going to dissect it. And we're going to take a look at the obvious things. So you have a mold that has certain dimensions, certain tolerances, And first thing we're going to look at is what is the shrinkage? Because obviously in this whole exercise, the likelihood that you're also going to be afforded the chance to retool pretty slim. And in many cases, it's not even necessary because there are plenty of materials that can be formulated to provide parts that meet your requirements from a dimensional standpoint in existing tooling. So we're going to look at shrinkage. We're going to look at water absorption. We're going to consider does the part change in dimension with moisture absorption, which we know nylon does, and what are the tolerances there. And then we're going to deep dive into the mechanicals. We're going to look at stiffness, strength, impact. We're going to look at the temperature effects. How is the material used? Is it elevated temperature? Is it room temperature? And we'll keep going down the list. We'll look at flammability. We'll look at ease of fill. What kind of flow rate might you need? Does the material need certain special requirements like a fogging value or FMVSS flammability, for example? So we'll go through and we'll try to figure out what materials might be in the hopper to consider. And this is the interactive part. This is what Polysource especially is quite good at. We've got 12 sales engineers who are all plastics trained folks that can sit down with customers and really have a technical discussion about what are the options, what would work, well, if we did this, what might the challenges be, etc. So, as you might have seen in some of the press that we've put out, what are the materials that are potentially open to us? So let's talk about nylon 6/6, for example. Why is it used in automotive, where it's used? Well, primarily it's because of its heat resistance and its ability to be used at elevated temperature. So a way to categorize these different material options is by looking at them from a heat distortion temperature or deflection temperature under load. And nylon 6/6 has an HDT of 260C. And in automotive, that has been the primary discriminator as to why you use 6/6 or why you can switch to 6, because you don't need that elevated temperature performance. So in the discussions today, so if you have to have 260C HDT, then that says all of those 5 below it won't meet the requirements. So what do? Well, the option then is you can go to a higher performing material like HTN or PPA, where the heat deflection temperature is 290C instead of 260. Couple of pros and cons. Some of the HTNs can be a little more difficult to mold. They're certainly more expensive. They might require hot oil, but they don't absorb as much moisture on the positive side. And again, keeping in mind that when you go to a customer and say your choices are, I can give you a material that's more expensive, but I can supply it, or I can ship you 0 parts because I can't get nylon 6/6, it's worth having the discussion with your customer. Nobody wants to take a price increase, but let's face it, if you can't get material, then a price increase is at least worth considering.
Cliff, I have a question here just to clarify. POK is polyketone.
Yes, that's right. Aliphatic polyketone, or POK. Some of you may remember Shell Chemicals' Carolon polymer from 20 years ago. It's now back on the market, made by a Korean company, Hyosung, and Polysource is one of the leading distributors for that material here in the U.S., and we have active programs to resurrect automotive approvals, and we're also having significant success in non-automotive applications replacing nylons and replacing POM. So thank you for that question. So coming back to temperature requirements. So if you have an application that's in 6.6 and it doesn't need the high heat requirement of the 260C, now you've got 5 potential materials to take a look at. You've got nylon 6, which is in many cases going to be the path of least resistance with your customer. It's a kissing cousin to 6.6. It's got plentiful supply. It doesn't use ADN or HMDA to be made. It's available throughout the world, and it's almost as good as 6.6. Almost. It absorbs a little bit more moisture. It loses a little bit more mechanicals when it absorbs moisture. But in many cases, those differences with 6.6 don't make a difference. And so nylon 6 is a real opportunity, especially in non-automotive where elevated temperature isn't needed. Then you have options like PBT or polyketone that are very similar to 6 in their processing. They don't absorb a lot of water, so that if you've got dimensional concerns with 6, then these two materials could be very interesting options. They both with glass fiber behave and shrink like nylon 6.6. In fact, I've run both polyketone and PBT materials in tools that were built for 6.6 and had no trouble hitting dimensional requirements. Both of these actually cycle a little faster than nylon 6.6, so there's an incremental possibility for faster cycle time. They're easier to dry. They don't absorb a lot of moisture. On the negative side, PBT without impact modifier is not as tough as nylon 6.6. But again, with the world of PBT, it's straightforward to be able to impact modify these materials and get to a level of impact that would be fully competitive with a 6.6. The polyketone, it's negative in natural color. It's not great for UV. If you color it black, it does fine. So you've got that trade-off there of color options and color limitations. Polyacetal or POM, again, with glass fiber, will run just like a 6.6 in terms of its shrinkage. It's not as good as impact. It doesn't absorb moisture. Not everybody likes to run POM. But again, when you're looking at options, especially in non-automotive, and in the case of POM or polyketone, these are two wonderful materials for wear and friction applications. 6.6 is also, of course, quite good. But as we dissect the data sheet and understand what are the requirements, if wear and friction is important, the polyketone and the POM could actually be better materials than the nylon, especially if you can't get the nylon. And our good friend, glass reinforced polypropylene. Let's face it, that why not look at a glass-filled propylene when you're looking at all the options? Yes, it is considerably different in terms of temperature and impact and strength. But what I have found over my long tenure in this business is a lot of times an engineer will pick a material because he's already using it somewhere else, so he's familiar with it. So he'll put an application into glass-filled 6.6 just because, well, I understand how it behaves. And that's very different from, this is what I have to have. And you'll find as you talk with Polysource that we'll ask these kind of questions. Tell me why you have to have the 6.6. Let's look at it from a technical standpoint, and we'll come to you with, here are the options. We think you should look at polypropylene among these others. And let's not miss the opportunity to really change the game for both the industry and for your customer and for you.
Cliff, I have another question being asked. Can you commit to the supply of PPA?
Yes. We can. We have 2 suppliers, and we're bringing on a third that have PPA basic production capacity as well as compounded capacity. That's a good question, because what we don't often talk about in the nylon world is that not only is 6.6 hard to get, nylon 12 is hard to get, 6.12 is hard to get, 6.10 is tight. Forget trying to get nylon 11. So there are supply challenges in all of the polyamides for a number of reasons, and each one is a little different. But right now, as you stack things up, there's plenty of 6 to go around, and there is plenty of PPA to go around, because PPA uses primarily caprolactam in its polymerization rather than the 6.6 backbone. So there are some PPAs that are going to be harder to get because they're based on modified 6.6, but most are based on 6, and those are have good availability. So kind of coming back to what we've been talking about. The time to act is now. Start the dialogue with your customer. Share your concerns, share your experiences on supply. Find out, have you been getting contract pricing? And if not, make sure that you get connected into that. And all of the resin producers have got very slick automated programs to be able to connect your purchasing into a contract. Same thing with the big distributors. If you're buying DuPont through Poly1 has the systems to make sure that if you should be getting contract pricing based on something that DuPont has negotiated, they can do that. You want to make sure that as price increases hit you, you've got to make sure that you pass those through immediately. You can't wait. And you need to be selling your parts based on today's replacement cost. Do not wait to implement a price increase on your parts until you buy. You will quickly fall behind, and nobody wins in that game. You need to get a forecast from your customer, and you need to put in orders with your supplier. Don't rely on blanket purchase orders. The highlight here is be prepared and start now. In the non-automotive side, same thing. You need to be in touch with your customer or your tier one. You need to tell them about what you're seeing, what your direct experience is. You need to pass through price increases immediately. You know, in this kind of an environment, hopefully you're not hearing, well, we're not accepting price increases, or this price increase is not acceptable. You know, it's one of those few times when, as processors, you have much more leverage than ever before to make sure that you have a seat at the table and that you're being treated fairly when it comes to material pricing. Let's face it, we all know that the processor gets squeezed between the resin producer and the OEM, and this is the time when you have the ability to fairly flex your muscles and make sure that you're treated as you should be. You're an important part of the supply chain, and you need to make sure that you're not put at a disadvantage. Especially in the non-automotive side, you know, be in touch with Polysource. I'll show you a second how to connect with me so that we can start the dialogue, help you with the questions to ask your customer, provide interesting, viable options to take to your customer, because let's face it, it's going to take some time, and there's no time like the present to get started. And even if you say to your customer, look, we want to submit some materials for you to make some tests, maybe we don't have to go to that route to actually switch, but you need to start testing now, because you don't know when you're going to call them and say, I can't get any more material. And so it's got to be impressed upon everybody that there's no time like the present, and this is an unusual opportunity where we actually know with some degree of certainty that supply is going to get worse. We don't know how much worse, but why sit back and hope with our head in the sand that it's not going to affect our business? The Boy Scout motto, be prepared. Thanks so much for joining today. I look forward to some questions, and I really appreciate you giving us the time today to talk to you about what I really think is it's an impactful situation on the industry, and I think as we work together, we can all get through it and continue to make money and to continue to grow.
Thank you, Cliff. We will have a few minutes here that people can enter any more further questions that they want to. Okay, great. We got a couple coming in.
So Cliff, first question is, do you happen, go back here. How is the supply situation going to affect fabric supply based on nylon 66? Did you happen to record this so you can send it to me? So any information you have on PA66 and the fabric type market?
Well, honestly, the big concern that I have is that fabrics, cable ties, and other 100% nylon 66 type applications are going to be the ones that are going to be hit the hardest. I didn't make the distinction that filled and reinforced polymer is advantageous for the producers, because if you're buying a 33% glass-filled 66 nylon, it only actually has 67% nylon in it. So for every pound of nylon, they can fill 1.2 pounds worth of orders. So the fabric business where you need nylon fiber, cable ties where those are generally neat polymer, those are going to be the ones that are going to probably bear the brunt. Cable ties is a very large market, but it has historically been one of the more competitive, lower price markets, and probably bearing the brunt of price increases because they're big buyers and generally at low price.
Next question we have, Cliff, is the situation. Do you see PA66 following the PA66 situation?
PA6 went through a tough supply period earlier in 2017. There were some maintenance issues. There was a planned plant outage. All of those are behind us. And so the information that we're getting from our key primary nylon 6 producers is that they see the situation with caprolactam supply, which is the monomer to make nylon 6, that capacity is in place, it's available, it's strong, and polymerization capacity is also present. So what we're being told is that nylon 66 availability is reliable over the next 3 to 5 years, and that there is enough suppliers of basic 6 polymer to keep up. And I should point out that in the world of nylon 6, there's probably a 3-to-1 ratio of 6 producers to 6 producers. So there's a lot more people with assets on the ground making 6 than there is 6.6.
And a very similar type question on nylon 612. You mentioned it before, but maybe worth repeating. Any situation, any expected situation there with the shortage of 612?
612 is tied back to the fundamental supply issues with nylon 12. Some of the basic monomer chemistry feeds both types of polymer, and that business really took some body blows after the explosion at the Marl plant in Germany several years ago. Probably 40% of what had been nylon 12 was switched away to other materials, and some of it was switched from 12 to 612. So there's still challenges on supply, and it's still a relatively finite group of monomer producers, much like we talked about this morning with ADN. All of the CDT comes basically from Evonik, and so that's a finite supply. There's small adjunct capacity, but Evonik still is the dictating things there in the 612 market. So I don't expect that anytime soon to get much better until more CDT capacity is put on.
Next question, does Polysource have partnerships and relationships with nylon 6 suppliers to support large conversion programs from nylon 6.6?
We have 2 6 suppliers that make polymer here in the U.S., and we also have relationships with Asian suppliers. So the answer is yes, we do have considerable capacity available to us to supply large opportunities.
Next question, will this shortage affect the post-consumer nylon resin market?
That's a great question. Cliff's opinion is that yes, the post-consumer and more specifically the post-industrial market will get tighter and tighter in its availability as people look to stretch and fill their 6.6 supply. So the first thing that will happen is if you're buying a post-industrial nylon 6.6 compound, you're going to see that price jump up dramatically. Just simple commodity economics. If there's no 6.6 prime polymer available, and the 6.6 prime polymer price is, I'm just going to throw a number out, $1.80 a pound, anybody that has post-industrial nylon 6.6, they're going to very quickly push the price up close to prime material. And so the margin squeeze that you'll get will basically push you to say, well, if I can get prime, why am I going to buy post-industrial? Because the pricing is almost the same. And our first-hand experience with our suppliers that offer the full range of prime, post-industrial, post-consumer, and even reprocessed regrind, we're seeing the bandwidth between the worst or lowest quality and the highest quality compressing, and they're all much closer today than they were a year ago. And to that point, if you have a customer that is buying post-industrial, while you may be able to still get material, your price is going to go up. So the discussion doesn't change with helping your customer understand why what he once chose because it was cost efficient is now just as expensive as prime material. So the discussion is there, and the options are still there. And I would say that if you're buying post-industrial 6.6 compound, first question you ought to be asking yourself is, can I supply a prime 6 at a cheaper price? Because that's what's going to happen to your economics.
Next question. What information do you have on current suppliers debottlenecking or adding more capacity?
What I have available to me would be what people have published, and I know that Ascend is working hard to get the message out about what they're doing. I know that Butte has announced through their joint venture partners the plans to expand. I think that plant is about 18 months away, so it's late 2019 or early 2020. But the monomer producers and the polymer producers have put out announcements, and so that would be the information that I'd have access to.
Next question. How long will it take to recover from the current condition?
Well, if you go back to my slide about the severity of the shortage, if demand remains as strong as it is now, and growth in new applications remains as strong as it is now, that's where you get to the 2021-2022 period when relief starts to come in, because the major ADN plant additions and plant capacity expansions kick in. And so what it looks like between now and 2021 is anybody's guess, and it's going to be based on new applications growth, car builds, and whether or not existing demand holds in there. What I have not delved into is if demand is at its utmost, in its worst case, if you will, in other words, business is so good, do the net capacity expansions that are due on by 2021, are they enough? And I don't know the answer to that, but I would hope that the monomer producers are looking at that and have taken that into consideration, that they're not putting on just enough capacity to get through or to keep things snug, but there's some room for the growth in our industry.
Okay, there's a question just came through. With this being said, should we expect prices to continue to increase and see further customer rationalization from suppliers?
The answer is yes. That's really my message today, that especially between now and the end of the year, I would expect at least another increase in the September-October timeframe, if not sooner. And I think because things are so tight right now, unfortunately, Ascend had a plant upset and they declared force majeure. I haven't heard if they're back up and running, but at a time when demand is so strong and every available pound is needed to have, unfortunately, a plant upset, anybody that's been in manufacturing knows that when you fall behind like this and you're running flat out, there's no way to make it up. And so that gap in supply and demand is just going to exacerbate the situation for the rest of the year. And that's really why I wanted to, or we at Polysource wanted to get out in front of this and say, be prepared. It's going to get worse. Start talking to your customer and plan for the contingencies, whatever you and your customer can work out and what we can help you with, but be planning for it, because I'm afraid it's going to get ugly before it gets better.
With these price increases, do you expect any market segments to fall away because they cannot support the higher prices?
Falling away, if I understand what you mean, is I think there are going to be net nylon 6/6 applications that do get converted to something else. whether it's a nylon 6 or a PBT or a polyketone, et cetera. But I do think that there will be some percentage of 6.6 demand that gets permanently changed to something else. We saw that with nylon 12. And I think, especially in the non-automotive segment, that definitely will happen.
That appears to be all the questions.
Yep, I think we've hit them all. So thank you, everyone. Just a reminder for the MAP members, if you log into your account and go to the webinar archive page, you can rewatch this if you'd like. If you want a copy of the PDF slides, please email Cliff at polysource.net and he can help you with that. And with that, I would like to thank you so much, Cliff and Jeff and Bob from Polysource. This was a great webinar. Thanks again, everybody. Have a great day.
Yes, thank you, everyone. And if we can help, my email is on the screen. My phone number is there. Send us a smoke signal. We're here to help. We want to see everyone succeed and get through what we think is going to be a tough climate for the next several years. Thanks again.
Thank you.